Hello everybody. Thank you for being here this afternoon. Can you hear me okay at the back? Yeah, good. Um, I'm just a speaker host today to look after our speaker, and welcome to the Orkney International Science Festival. It's great to see you all here, and this session is on Viking genes and genomic medicine, and our speaker is Professor Jim Flett Wilson. Who many of you will already know very well indeed, I should think. So Jim is going to talk about the opportunities for the prevention and early detection of disease for Orcadians and Shetlanders from the Viking Genes study. He's affiliated both to the Usher Institute and the MRC Human Genetics Unit. Originally of Fair Isle heritage, he grew up in Orkney, went to the local Kirkwall Grammar School, and went on to read genetics at the University of Edinburgh. So after a year working with Svante Parbo in Bavaria, Jim went up to New College in Oxford, where he completed a DPhil in human population genetics with David Goldstein. He moved back to Edinburgh in 2003 after a stint at University College London to take up a Royal Society University Research Fellowship. Now, over the last decade, Jim has led 2 large genetic epidemiology studies in Orkney and Shetland, which many of you will be aware of. These platform resources for health research have contributed to the discovery of over 1,000 novel associations, which he's going to talk all about. Okay, well, thanks very much, Jim. Over to you.
Thanks very much for the introduction. Thanks everybody for coming, and I'd like to thank Howie and the festival organisers for inviting me. As was said, I'm going to talk about Viking genes and what it means for genomic medicine. So most of you in the room probably know about Viking genes studies, but I'm going to go through them quite quickly to bring everyone up to the same speed. And I'm going to highlight some of the studies that have been in the press last year and this year about the breast and ovarian cancer genes BRCA1 and BRCA2. Then I'm going to broaden out the discussion a little bit to talk about other variants that have similar effects. We call them actionable findings, findings you can do something about. Then I'm going to go in a little bit of detail to 10 findings like this that we call founder variants, variants that have become very common in Orkney or in Shetland that are vanishingly rare elsewhere. These are important variants for the people in this room. I'm going to tell you a little bit about where they come from, different parishes and isles in Orkney and Shetland. And then we're going to move on to a slightly different kind of variant that's important if you're a carrier and you marry another carrier. And finally, I'm going to round off with a little bit of a look at the strategy of the Scottish Government in this area, in the area of genomic medicine, because I think there's a very good opportunity here for screening that's not being taken. So, as many of you know, the Viking Genes studies began nearly 20 years ago now in Orkney. In the Orcade study, we then moved on to Shetland in the Viking Health Study Shetland, or Viking 1, and recruited 4,000 people altogether. We then moved more recently onto the Hebrides, and we've recruited another 2,000 people in the Hebrides, as well as further people from Orkney and Shetland, for a total of 10,000 people. But in the more recent studies, you didn't have to live in Orkney or Shetland, so we were able to recruit the extensive diaspora of people who have genes from Orkney, Shetland, or the Hebrides, but they live elsewhere. You can see there are many people from the Northern Isles who live in Aberdeenshire and near Inverness, and then there's a huge number of people, islanders and their descendants, who live in the central belt of Scotland. And indeed, we discovered diasporas we didn't know about. There are many, many people, myself being one of them, who live in England, in the towns and cities of England, who come from Orkney and Shetland. And indeed, there are people all over the world, in the colonies, the former colonies, and also in other places from Oman to Japan and from Thailand to Hawaii. The people of Orkney and Shetland have gone everywhere around the world. So the people who joined our studies were all adult volunteers, and the criterion was to have 2, 3, or 4 grandparents from Orkney or Shetland, and finally from the Hebrides. And the first thing that we actually discovered, we were interested in the ancestry of these populations, but we realized that they had really quite distinct gene pools from the gene pool that we see more generally in the rest of Scotland or indeed in England. So I call these populations founder populations. They were founded, they were by a small number of founders, by people who actually started this population, people who are ancestral to many other people in the population today. We confirmed that there was a Norse component, as everyone liked to think, which makes the population somewhat distinct. But I think quite a lot of it was simply due to isolation. Through the centuries, over time, the channels of sea and the other barriers prevented free interchange and marriage with the mainland. And so these places developed their own gene pools, generation by generation by generation. And this has led to the phenomenon that we're here to discuss, these founder variants, these variants that are elsewhere very rare, but have increased dramatically in frequency, such as the BRCA1 variant in Westray and the BRCA2 variant in Whalsay in Shetland. And we've also different from other studies in that we're one of only 2 in the UK who have the ethical permission and the consent to return these kinds of results to the volunteers themselves. And this, I think, is saving lives. You can hear much more about that in Shona's talk, which follows. So, distinct gene pools, I say. This is the first graph I'm going to show you. It's very simple. Each dot or plus sign or X is an individual, and there are 40,000 individuals plotted here. And how close together or how far apart they are tells you how much DNA they share, how closely related they are. And what immediately stands out is that Orkney here, Shetland here, are completely separate from all the others, even from people on the Scottish mainland. And this is actually rather similar to the Jewish populations here. So across the whole of the British Isles and Ireland, including many, many different populations, Orkney, Shetland, and the Jewish populations stand out, completely different from everyone else who are in this sort of splodge here. The Welsh are the next most different. They're trying to separate. But it's important to remember I have no Hebrideans in this plot. At this point in time, I had yet to recruit any Hebrideans, and I would predict that they will also separate out. So what this means is that there's many genetic variants that are rare or even completely absent elsewhere, but they're shared among these genetic islands here. And that's the very definition of a gene pool. This gene pool is slightly different from this gene pool, and that's what this is all about. So I'm going to tell you about one of the consequences of this. This variant, this founder variant in the BRCA1 gene, most famously carried by Angelina Jolie here. So in 2018, we received some really brand new data from our partners in America, the Regeneron Sequencing Center, which allowed us to look at every gene in the genome and to look at every variant in the coding parts of the genes for the first time. So it opened up a sort of new horizon that we hadn't been able to look at until that point in time. And it revealed that there was a disease-causing variant in this gene BRCA1. It causes a hereditary syndrome where the people are at a much higher risk of breast and ovarian cancer among the women. And we were very shocked that there were 20 carriers in orchids. This is a huge number. Otherwise, you would not expect to see anything like this. Indeed, the NHS, the Grampian Clinical Genetics Service, already knew about this variant, but it's 470 times more common in Orkney than it is in a general UK population. And 1% of a random sample of Orcadians carries this gene. So it's really, really enriched. And this is where I begin to get the idea that there's something we ought to be doing about this, perhaps screening the population. But I also wanted to know, where did it come from? Was it smeared all across Orkney, or did it have a focus? So, of course, we have a lot of information in our studies, and we were able to plot this graph of where the grandparents, so we have our 20 carriers, they each have 4 grandparents, and so we can count where do all the grandparents of the carriers come from. And you see here, there's a huge excess of Westray grandparents. And in fact, Because we all have 4 grandparents, but we only inherit this gene from one of them, the true figure is 95%. And all 95% of the carriers had at least one grandparent from Westry. So it really looked like the variant came from there. And when we drew family trees, tracing back in time, in fact, everybody, even the last guy who had no grandparents from Westry, he eventually traced back into Westry families. So here at the bottom, we have people who joined our studies. In red outlines are the carriers of the BRCA1 variant, and they go back and they join together, and everyone comes back to Westry ancestors in the 18th century. I actually believe this variant probably occurred around about 1650 in Westry, and it's been carrying down the generations all the time since. So we have a strong representation of Westry grandparents, and in fact we can link everybody back to Westry, but I couldn't quite link them all together using family trees. And so the reason I know it all comes from one source is when we look at genetics. So these graphs show how much DNA two people share, and each of these pairs of people are carriers of the BRCA1 variant. And you can see in this thin piece of DNA here, everyone has this bit, and this is where the BRCA1 gene is. This is the exact same piece of DNA inherited from a common ancestor more than 300 years ago. And this is why I know it only occurred once, and that person lived in Westry. We actually found people in the large UK Biobank study, so it's a study of 500,000 people, principally in England, and we found a small number of carriers, and they had not just the Westry variant, they had the Westry haplotype as well. They shared this piece of DNA, which showed that even if they don't know it, they have ancestors from Westry. They've just moved down and been sampled. And we even found one in Nevada, in the Healthy Nevada project, also with the Westry signature. So people, as we've seen in these maps of the diaspora, have been taking the Orkney genes and spreading them around the world. So, as I said, we had 20 carriers, and we found 7 more carriers now in Viking 2. So really quite a large number. And to these can be added obligate carriers. So if we have a woman, for instance, and then her mother's sister's son, and they're both carriers, we can infer that both the sisters, the parents, are also carriers, because that's the path that the variant would have taken through the family tree. So we can add another 9 obligate carriers in this way. And as more testing happens, more and more of these people will turn up. It's a significant number. And this discovery was one of the reasons why some pilot funding was awarded to the NHS, part of it coming from the Westry Development Trust, to carry out a screen of Westry people who live in Westry. This is my colleague from the University of Aberdeen, Zofia Międzybrzoska here, who led this very small pilot. But I think that's nothing like enough. What we really need is a population-based screening, regardless of whether you've been ill with cancer or have it in your family or not. And this should be for all people with Westry ancestors, whether they live in Westry, whether they live in the mainland of Orkney, or whether they live in the mainland of Scotland. This is what we need. This would be equitable. So I'm going to take a little aside now to remind those of you who were in the ORCID study how we went about it, and to inform those of you who don't know about the ORCID study how we went about it, because it wasn't like very many other health studies that you might hear about. I had to buy a Mercedes box lorry and get it fitted out into a mobile clinic / lab / nurse's office / waiting room, and then drive it up to Orkney. And we went around 4 of the different North Isles: Westry, Sandy, Stronsay and Shappensea. This picture's taken on a nice day in Sandy. And this is where many of the people came in and gave blood, answered their questionnaires and were measured. Here, of course, the bloods had to be taken to the lab in Kirkwall every day to have the different measurements done. You can see one of our nurses, Linda, here, who's also an air marshal at the Westry Airport as the little plane is flying to Kirkwall. Then some of the bloods were also kept in a freezer on the island. And this is actually a rather grim day at Gill Pier in Westry, and I'd driven a pickup truck up from Edinburgh with half a ton of dry ice on the back in all of these large tubs to take all these precious aliquots, these precious samples, back south so that we could measure many different risk factors in them. And here's a picture of me on the short sea ferry going across to Gills Bay with all of the samples safely in the back, with just a rather long drive back to Edinburgh till they were in safety. More of you might remember the clinic that we rented on Victoria Street here in Kirkwall, which is where we measured many more people. It looks a little bit unwelcoming here because I took this photo in the Christmas holidays. And these are, of course, the BA barricades to stop the BA scrum falling through our plate glass window. Here are a couple of pictures from inside the clinic. Here we have one of our research nurses performing pulse wave analysis so that we can measure different features of the strength and the timing of the pulse that are important predictors of future heart disease. And here we have another research nurse modeling our DEXA scanner, which we use to look at bone mineral density, how strong your bones are, and also to look at the different fat distribution in your body. So I hope that jigs some memories for those of you who are in the study. Now, I'm going to move on to our findings from earlier this year from Shetland. It was a very similar story actually to that in Westry, because in one island in Whalsay, we found a BRCA2 variant. So this is another gene, quite similar function, that when you have a variant in it, it increases your chance of breast and ovarian cancer. But critically, also, if you're a man, unlike BRCA1, BRCA2 variants increase your risk of prostate cancer and male breast cancer. So this actually affects a broader swathe of the community because everyone who carries it is at risk, not just females. We found 10 carriers in Viking 1 and 5 more in Viking 2. So it's not quite as common. About 0.5% of Shetlanders are carriers. This one is 140 times more common in Shetland than in the general UK population. And once more, NHS clinical genetics were aware of this variant, but I don't think they realised it came from Whalsay. We know they do come from Whalsay, however, by doing the grandparents graph. Again, this time 39% of grandparents are from Whalsay when you count up all the grandparents. So 10 people have 40 grandparents. But if you count how many have at least one Whalsay grandparent, you realise that 70% of them have a Whalsay grandparent. So it's not quite as tight a connection. But nevertheless, here's the island of Whalsay. In the same way, the pedigrees tell us everything. So again, we have our participants and volunteers here, and they trace back through complex pedigrees back in time, sometimes to 1786, and everyone inside the blue line was born in Whalsay. So it very much goes back to one place again. This one I think is a bit younger. It might have happened at some point between 1700 and 1750, which is why it's less common. It takes time for variants to become more common. I know that it's from one source in exactly the same way as I know for the Westry variant. We have this strong overrepresentation. We have this links back, not everyone this time, but most people to Whalsay. And we can't quite link them all to one individual. They're just in Whalsay people, and we can't link them because the records run out. But we can use this same digital barcoding DNA trick by looking at lots and lots of markers all over the place. So this here is a representation of the carriers and all their different DNA markers across a piece of DNA. And it's a bit difficult to see, but when I put the red box around it, you can see much more clearly they're completely identical in this middle bit here. It means they all descend from one person, the one person in which this mutation happened, this change in the DNA that increases their risk of cancer. And at this point, we began engaging more with our participants, and it's very moving, some of these stories. This is Christine's story, who's a participant in our study and a carrier of this variant. She said, in October, I went for a mammogram where they found out that I have breast cancer. I am so grateful you told me I have BRCA2, as my next mammogram would have been in another 2 years. It might have been a different story. So she went for a mammogram because she received my letter telling her she had a BRCA2 variant. In January, I had a double mastectomy and they removed lymph nodes to be checked, and I finally received the all clear in March 2024. So she literally says that we saved her life. We could have saved her life. This is very powerful stuff, and it's what motivates me to direct our research going forward to do more of these things, to be able to use all the data we have to help people like you. So let's have a look at these BRCA variants and put things in context. So I'm talking about them all the time, and you're probably not aware how common or rare they are. So in a large sample, in 500,000 people from the UK, mostly from England, about 1 in 260 people carry a BRCA variant, cancer-causing BRCA variant. There are 424 different variants that they could carry, so many, many different ones, each of them individually rare, but it adds up to about 1 in 260 carrying it. In the Ashkenazi Jewish population, so the Jewish population who lived in Eastern Europe for 1,000 years and who are the Jews who live in and around London today, about 1 in 41 carry one of 3 of these BRCA variants. So this is a founder effect like what we see in Westry and what we see in Whalsay, where their separate gene pool has allowed this variant to become very, very common, these 3 variants, sorry. And then if we look at some other populations, we see that in Iceland, to the north, 1 in 138 people carry a BRCA variant. They have one BRCA2 variant in this case. Then if we look in Orkney, 1 in 105 carry the Westry BRCA variant. And if we look in Whalsay, 1 in 43 carry the Whalsay variant. But rather shockingly, and the highest so far in the world, 1 in 19 people who have all 4 grandparents from Westry is a carrier of the BRCA1 variant. So this is very, very extreme, going to twice the rates that are found in Jewish populations across the world. So screening is deemed to be cost effective in Jewish populations, in Israel, in New York City, and now in England. It's performed in Iceland as well. So it's clearly required in Orkney and Shetland as well, looking at these figures. And I think it's actually an opportunity here because we don't have to look at hundreds of different variants. So we had 1 in 19 from Westry, we had 1 in 43 from Whalsay. But another important point is that very few other BRCA1 or BRCA2 variants were found in the survey. Remember, there were hundreds in the large sample in England. In our study, 93% of all of the BRCA variants were accounted for by these 2. And the few others that we saw, some of them, they had one parent from Orkney and one parent from Edinburgh. Clearly, this other variant had been brought in to the gene pool. So this is simplification of our gene pool. And that itself is an opportunity. It means it's cost effective. It's far cheaper to screen for 2 variants than to screen for 369 variants, which is what we'd need to do in England to reach 93% coverage. It doesn't cover absolutely every single possibility, but we would want to do these low-hanging fruit first so that all of these people can find what they need to find and others are given peace of mind. So I'm going to broaden out now from the breast and ovarian cancer to a broader definition of actionable findings. So actionable findings are harmful gene changes or variants which are linked to serious diseases which can be prevented or improved by NHS treatment. These are not things you can do nothing about. These are things you can do something about. You can take action, and that's why we call them actionable. In each case, early knowledge of risk could enhance how well the preventative measure or the cure work. So these things are beneficial to know. You would want to know them so that you can take action. And in our analysis, we used a list of 81 genes that was put together by the American College of Medical Genetics. So these include the hereditary breast, ovarian, and prostate cancer genes that we've been talking about, but also hereditary bowel and womb cancer variants, also inherited high cholesterol that can be passed down in a family, and if it's untreated, commonly leads to heart attacks. There's a group that cause fatal heart arrhythmias. Shona's talk will mention more about a particular heart arrhythmia that can cause sudden death. There's a group that are called cardiomyopathies. So this is a disease of the heart muscle causing a weakening of the heart muscle, and if untreated, can lead to heart failure. And finally, there's a more diverse group of metabolic diseases, such as the iron overload disease, hemochromatosis, which, if left untreated, can lead to liver failure and death. So in the Viking 2 study, in the Viking 3 study, in the online studies, we consented people at the point of recruitment, and they could opt in to this return of results. Everything else you had to consent to, this was an optional extra. And I was very happy to see that 98% of people opted to have these results, while 2% exercised the right not to know, and that's fine as well. Most of the genes are related to heart and vessel disease, The next category are cancer-related genes, and then there's a diverse group, miscellaneous and metabolic at the end. Now, this work involved a piece of software, a service provided by the National Library of Medicine called ClinVar. So this stands for clinical variation. And I'm just going to highlight it here for a minute or so because it's extremely useful. It's basically a place where clinical geneticists all across the world can put their data together. So we're working with rare things here that are difficult to interpret. So the more people that put things together, helps everyone else then to understand what's going on. And we made great use of it in our studies here in Orkney and in Shetland. ClinVar tells you its interpretation of the clinical significance. Is this variant disease-causing? Is it likely disease-causing? Is it not disease-causing? It also provides a number of things like the number of people who submitted information about it, so you can weigh up how much evidence is there that this variant causes cancer or whatever other disease that we're interested in. Now, it should be simple. We simply take the variants that we saw in Orkney and we see the variants that are in ClinVar and we just match across. But it's really non-trivial. This took an awful lot of work because of differences in nomenclature and other little wrinkles. But we got there in the end. We're also very careful. We want to be completely certain before returning results to people. So we validated everything by a second method. Everyone who gets a letter has been measured twice at least, so that we're completely certain. Here's an old-fashioned sequencing trace showing one of these variants. So what did we find? Well, we had 4,100 or so, 4,200 people from Orkney and Shetland, and 102 of them, or 1 in 41, I don't know why it's always 1 in 40 something, but carried an actionable genotype. There are actually 107 different actionable genotypes because some people with very bad luck had inherited 2. So they may have inherited a cancer one and a cardiovascular one across 23 different genes. And because of these founder effects, this huge increase in frequency of BRCA1 and BRCA2, unlike the previous graph, the great majority of these guys had a cancer variant. That's very specific to Orkney and to Shetland. So what else did we find? Well, I'm going to tell you a few examples here, just so you get a flavour of what's going on in the gene pool in Orkney and Shetland. There were genes for Lynch syndrome, so that's an inherited bowel cancer, but it can also cause endometrial or womb cancer in women. We had various other kinds of bowel cancer and different variants that sometimes cause thyroid cancers. We had a number of variants causing a particular arrhythmia called long QT syndrome that can result in sudden death. And then a more miscellaneous group of different metabolic ones, including a disease called hereditary hemochromatosis. Now, hemochromatosis is a disorder of iron overload, where the body becomes saturated with iron, which eventually harms many of the tissues. And it's actually most common in Scotland and in Ireland. People call it the Celtic curse. And I've been very happy to recently win a small grant from a charity called Hemochromatosis UK to do a little bit more study into hemochromatosis in Scotland. What we've been asked to do is to create a map, a little bit similar to this old map of mine, looking where red-haired variants are found across Britain and Ireland, so we can find out where these hemochromatosis variants are most concentrated in Britain and Ireland. We're going to use data from Viking Genes and a number of other similar studies that we have access to at the University of Edinburgh. Why do I want to do this? Not just because I like drawing pretty maps, but because we want to know where it's most common. Because if we want to do a screening for this disease in the future, and money is limited, as it always is, you want to go to the place where the variant is most common, because then you're going to get more bang for your buck. You're going to find more people with the disease. So it's a preliminary to possibly doing future screening across the country. So I mentioned in the outline that we found 10 founder variants. These are the important variants. These are the variants I think we ought to be screened for. So you know about 2 of them, BRCA1 and BRCA2. We also found 3 variants that cause a disease called Wilson disease. So this is nothing to do with me. Another guy called Wilson described it. And this is a disease of copper accumulation in your tissues. And if left untreated, it can lead to brain disease and liver disease. And you can see here that one of them is 180-fold more common in Shetland, and it comes from Burgh Isle. Another's 350 times more common in Shetland. This one's 60 times more common in Orkney. So each one seems to come from a particular place. We also have two variants causing the cardiomyopathy disease, this weakening of the heart muscle that can lead to heart failure. One of them is 700 times more common in Orkney and comes from families in the west mainland of Orkney. But look at this one here. It's nearly 4,000 times more common in Shetland than anywhere else. When we looked in a database of 500,000 people, we only found one example. And these guys all come from the Isle of Yell in the north of Shetland. Then we have some bowel cancer associated ones. And finally, a variant associated with a rare disease called Pompe disease, which causes muscle weakness, particularly of the heart, which obviously isn't a good thing. These two are also Orkney variants. This one's 70 times, both of them about 70 times more common. One particular to Westray and one to St Andrews in the east mainland of Orkney. So these are all at least 50 times more common than in the general UK population. This is another way of conceiving of the gene pool. This is the part of the gene pool that matters. All the rest of it, it doesn't really matter. These things matter. The gene pool does matter. And I think it's a clear and obvious opportunity to design a screening panel, not just to scan for BRCA1 or BRCA2. Why not scan all 10 of them at once? One spit sample, problem solved. That's what I would like to do, and that's what we're aiming for. So I don't have to lecture this audience on the parishes and isles of Orkney and Shetland, but there are actually 50 parishes and isles across both archipelagos put together, and I highlight them here because of this very local nature of the variation that we see. Only 2 of these founder variants were found in both Orkney and in Shetland. One of them, for the cardiomyopathy, was found in some Shetlanders who had some recent Orkney ancestry. So it came from Orkney and it had moved to Shetland and then expanded there. Another one related to bowel cancer was, I think, introduced into Orkney and Shetland separately, probably from the mainland of Orkney. But all the others are very specific. We've covered the Westray BRCA1, we've covered the Whalsay BRCA2, but 100% of the carriers of this long QT syndrome variant either go back to the area of Ade in Shetland or to the Isle of Unst in Shetland. 80% of these Wilson disease carriers go back to Burgh Isle, 100% of this cardiomyopathy variant go back to Yell, and so on and so forth. It's very, very clear that they're coming from a single source in most cases. And I think this might be important for screening. But of course, these small communities are breaking down now. Everybody moves to Kirkwall, everybody moves to Lerwick, and these things get mixed up. So I begin to now think, actually, everybody should be screened. Many people don't even know where their granny or their great-granny comes from as people get more and more mixed. But what I also noticed was how clearly this pattern of these actionable variants coming from one place matched up to a paper we wrote 5 years ago where we could see that each of the different islands and many of the parishes had different gene pools. I didn't know it at the time, but we were predicting what we were going to find. So I now know if I see this pattern anywhere else, there probably will be BRCA variants and cardiomyopathy variants and so on and so forth to be found. And why has this happened? It's because of the history of marrying very close to home. This is a plot showing for all the marriages that took place in 1861 in Orkney, how many of them were contracted between spouses who were born in the same place. So 90% of so in all the marriages in North Ronaldsay in 1861, 90% of the spouses were both born in North Ronaldsay. And then when we look at Hoy, it was 75%. When we look at Rousey, it was much the same. And so it goes all the way through the spectrum till we get to Kirkwall, where only 10% of the spouses were both born in Kirkwall. So people in the outlying districts married very, very close to home over many, many centuries. And that's what created these pictures. Using data from the Orkney Family History Society, I dug into this a little bit more, and we can see in Westray in 1851, 90% of the people in Westray were born in Westray, and 55% of them shared the top 10 surnames. And it's not only the outer isles. In Bersey, in the West Mainland, 85% of people who lived in Bersey in 1851 were born in Bersey, and 62% of them the top 10 surnames. Different surnames in different places. Rendell, Draver, Harkis, Sater, obviously in Westray, while in Bersey we have Spence, Johnston, Moore, Tellier. And we see these things going through the years from 1851 to 1911. It hasn't really changed very much. And we see it in Whalsay and Shetland as well, even more extreme. 92% of the people in Whalsay in 1911 were born in Whalsay. And 70% of them had these kinds of surnames: Irvin, Anderson, Polson, and so on. So people have married very, very close to home, and Westry has been very well studied over the last century. This is data from a GP who lived in Westry last century, and what he did was to take everyone born in Westry from 1855 for 100 years through to 1955 and work out how far apart the bride and the groom were born. A huge, huge amount of work, but it was incredible. 40% of them were born less than a mile apart, and 3/4 of them were born less than 3 miles apart. So with this kind of marriage patterns is what creates the gene pool things that we see today. So I'm going to now go on to a different kind of variant, these carrier variants where you need to have 2 copies of them, because the regional gene pools here are important. Again, we've done a large survey looking across Britain, and I'm just going to highlight one element of it here, because what we see is looking across Scotland, where has a founder effect happened? Where is there a variant that's much more common than elsewhere? Shetland, Shetland, Orkney, Shetland, 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 Orkney. It's completely screaming out compared to other places. And the important one here is this neuronal ceroid lipofusionosis 1, also known as Batten disease. This is actually shocking because 1 in 41 people in Shetland are a carrier of this disease. They are not at risk themselves, but if they married another carrier, they'd have a high risk of having this fatal disease. And I think that this is another suggestion to us that we ought to be screening for these kinds of things. But this is a different kind of screening. It's called reproductive carrier screening. So I'll explain this to you. It involves understanding what recessive inheritance is. So this is the kind of inheritance where you need to have 2 copies of the variant, one from mum and one from dad. So people who only have 1 copy are unaffected. They don't have any symptoms. But when 2 carriers get together, as in this diagram here, here's a carrier and a carrier, 1/4 of the babies will have the disease. 1/4 of the babies will be completely free, and half, that is, of the babies will be carriers themselves and could carry this on to the next generation. And you know examples of this, like cystic fibrosis, albinism is an example of this, but also Batten disease, Cohen disease, Wilson disease, Pompe disease, Bardet-Biedl disease, that's important in Orkney. So I actually think we should do screening for these kinds of diseases as well. It needs to be done ahead of reproduction. So young people who are about to start a family, students going to university, perhaps even sixth formers in high school. All of these groups are screened in Jewish communities already in Britain, in London today. If individuals are not carriers, they have peace of mind. They don't need to worry about it for the rest of their lives. If they are carriers, they could choose to marry a non-carrier, or they could get their future spouse tested. And if both partners are carriers, there's still things that can be done. They could choose to have IVF and use embryo selection to choose this embryo and not this embryo, and thus avoid having a child with a fatal illness. So I'm going to give you one example of this, and it involves me. So 17 years ago, I took a genetic test with a commercial testing company, 23andMe, and here it says, Jim, you have one of the variants we tested in the CFTR gene. So I'm a carrier of a rather famous mutation called delta F508 that causes cystic fibrosis. But I don't have cystic fibrosis, but it means that my future children would be at risk. It's actually very, very common in Scotland. This disease is most common in Scotland and in Ireland. So I was partway through having my family at this time, and I arranged to have the mother of my children tested via the NHS. And happily, she was not a carrier. So we went on to have 2 more children, and all 3 of our children, none of them have CF. So this is reproductive carrier screening happening 17 years ago. And it's not only happening because geneticists have earlier insight into this, it's happening in Britain today. It's happening through the BRCA program, the Jewish BRCA program. People are eligible to be tested for BRCA if they have 1 Jewish grandparent and they receive NHS care in England. It's not available in Scotland yet. And I think something like this is what we probably want in Orkney and Shetland. You don't have to have a family history of disease. You don't have to have disease yourself. And it's done postally by saliva kits. The Jewish population also have a project called Genetics, and this does reproductive carrier screening. They screen for 47 different diseases that are much more common in Jewish populations. And it may be that we need something like this, perhaps starting in Shetland, where these things seem to be more common. I'm just going to skip these in the interests of time. So coming now to the end of my talk, I want to explain the situation that we have in Scotland. So Orkney's own Neil Gray signed off on this genomic medicine strategy for the next 5 years in Scotland in April of this year. And I'm very keen, as you can tell, on genomic medicine. In the executive summary, they say our vision is to establish an equitable, person-centered, rights-based genomic medicine service. Sounds good, right? And they have a lot of talk in this document, a very big document about equity of access. We will identify barriers to equity of access. We recognize the multiple factors contributing to inequity, including location, acceptability, socioeconomic factors, race, ethnicity, and so on. But nowhere in the document do they ever mention founder populations. They don't mention distinct gene pools, and they don't mention population genetic screening. I think we need a similar program to BRCA and genetics in the Northern and Western Isles, and including their diasporas on the mainland. And it should include the actionable variants like BRCA1 and BRCA2, and it should include the carrier screening like Batten disease and these other diseases. And I think we could even be an exemplar for the future of medicine across the whole country, where they maybe want to be screening for hemochromatosis and other diseases, if we can deliver this successfully in the Northern Isles. And we were happy last year when Humza Yousaf, who at that time was the health secretary, noticed our work, said it was hugely important, and said extending the screening was something the Scottish Government would consider. So we'll see where we get with that. I have some meetings with ministers lined up in the coming weeks. I want to draw your attention to Shona Kerr's talk and encourage you to come to it at 3:30 today, where you can learn lots more about the return of results process that I've rather skipped over here. So in summary, I hope I've persuaded you that we have distinct gene pools in Orkney and in Shetland, and that this ancestry is important for genomic medicine. It's not just interested because we're slightly interested in our past. It actually is important for our future as well. These founder variants, the fact that some of them have become much more common, and this simplification, there's not actually that many of them, it's a golden opportunity for cost-effective screening. But the genomic medicine strategy in Scotland is not presently equitable across the UK. And I would like one of the legacies of Viking Genes to be that we fix this. If you want to learn more about our work, please visit our website, viking.ed.ac.uk. You can learn about what we do, about public engagement, read volunteer stories. We have a new section on media. You can look at back issues of our newsletters. We're very keen on putting lay summaries of all the work we do, so you can read about all the different papers in lay language to see what we're up to. It only remains for me to acknowledge many, many people, too many to mention here, and many different funding bodies through the years. But obviously, of course, my main thanks goes to all the volunteers here in the audience and anywhere else without whom we couldn't do this work. The last word I have is to point out the Viking Genes Fund, which we've just launched a few months ago. The traditional funding bodies have started to not support us anymore as we've moved more into this screening area. But we'd like to continue our research to save lives and to highlight risk in particular places and hopefully to influence policy. So please help support our work by going to viking.ed.ac.uk/support-us. Thank you very much.
Thank you very much, Jim. That's absolutely fascinating. We do have a few minutes for questions. I've got a couple that have come in on Slido, and you can still add more if you want to. And we also have a roving mic, so if anyone wants to ask a question, put your hand up and we can bring the microphone to you. I'll start off with one of the ones that's come in on Slido then. Do you know of similar projects in Europe, and are patterns like this found in other places?
Yep, so I think it's turning out that this is the normal state of affairs in places that are not large urban conglomerations. So in Finland, they have a suite called the Finnish Disease Heritage of, I believe, 20 or more different variants. In Sardinia, they have their own heritage. And I think in many, there's also various mountain valleys in Italy. The more you look, the more this is found. So this is normal. This is what we expect
Yeah.
when people take a wife from a mile away. And it's not abnormal. And this is what we have. So I think it's up. People are used to thinking in a city mentality, and people have been mixing and mashing for centuries, but not everywhere is like that.
Okay. Thank you. Any questions with the roving mic? Got one coming up over there. Oh, okay. There we go.
With the Hudson Bay Company, has anybody looked at Canada and where the Hudson Bay were concentrated? Because there were an awful lot of Orcadians went there.
Yeah, so I sometimes have contact from Canadian geneticists who work with Cree people and others in parts of Canada, saying, "Have you seen this in Orkney? We have a lot of this variant here, but so far the ones they have, we don't have." So I haven't seen a connection so far. But then Orcadians are not the only people who contributed to those populations, so they must have come from somewhere else.
Okay, thank you. There's another here for the roving mic.
Thank you so much. I'm really staggered by your results. They're just extraordinary. How did you find all these Orcadians in the diaspora in England and all over the world?
Yeah, good question. We are lucky that we've had two excellent communications managers who use the power of social media to get to people. We also benefited enormously from help from both the Orkney and the Shetland Family History Society, who are willing to do mail-outs and reach their, because of course they have many members all over the world who have ancestry from the islands. There was also no doubt word of mouth, many articles in print and broadcast media. I'm sure there's thousands more out there who didn't hear about us, but we were very happy to be able to recruit those that we did.
Thanks very much. There's one right up at the back, and while we're going there, I'll ask you this another question from Slido. What are the main factors, if known, that switch on the BRCA genes and thereby risk developing the various cancers associated with them?
And I'm not an expert in the control of gene expression, but everyone in the room has a BRCA gene, and they are switched on because their job is to protect us. And it's when people have inherited a change in this gene that means the BRCA can't do its normal function as well, that increases your risk of cancer. So I'm not sure it's so much to do with switching on and switching off. It's to do with the function being degraded, and over time and over time and over time, that increases the risk of cancer.
Okay, thank you. So up at the back there.
It's slightly facetious, but I notice that you don't mention Fair Isle in any of your things.
Yeah, but that would take a whole lecture. Fair Isle's a very interesting place, full of geniuses.
Okay. Anybody else?
There's one over, two
yeah,
over
we've got
here.
a couple here.
Thank you very much for that. I've got both Yell and Whalsay grandparents. My children are now in Edinburgh. Should I be testing, or is it still possible to test and pass on information for them to follow up?
It's not possible at the minute to get a test. So our recruitment closed last year because funding ended. And as a general member of the public, you can't access these tests. We were able to get the so-called genomic test directory changed so that if someone develops breast cancer at any age and has a grandparent from Westry, and we hopefully are going to get it changed for Whalsay as well, they could get a BRCA test. But that means you have to have cancer. For members of the public who don't have cancer, this mechanism doesn't exist. But that's what I would like to eventually get funded and make available. And we're trying in the background to get this started. It would probably have to start in Shetland itself and then move out. But it's costly. It costs a lot of money. And it's difficult to persuade people that, of course, you're going to save money. You have to upfront test 10, 20,000 people, but then you're going to save money from all the people that you've saved from requiring cancer care and end-of-life care. But that's somebody else's budget in 20 years' time, so it's a hard argument to make. But it should be done, and we will get there, I think.
Have you made any connection between Westry people and the Ashkenazi Jew? And the reason I ask this is a close family member did another genetic spit test that you send away for. We're very much from Westry and found that we had very close relations that were Ashkenazi Jews in the States.
I see absolutely zero connection between Westry or any Orkney or Shetland or Scottish population and the Ashkenazi Jews. It may be that the test was flawed, depends which company it came from. When I say they're similar because they've had a similar history, but the Jews had this history and the people of the Northern Isles had this history, and there was zero.
Yeah.
We
do have an unknown great-grandparent.
The person did?
In our history,
we
have an unknown, and we assumed that they were Ashkenazi Jew.
Yeah, I mean, of course.
But it seemed a funny coincidence.
But that's quite possible. If 1/8 of your genome, you don't know where it comes from, it could be. The test you take will tell you that. It's very easy to recognize Jewish ancestry because of they're having a distinct gene pool. So if a high quality test would be able to tell you if you were an 8th Jewish. I don't know. People move all over the world and they mate with one another. So I have no idea. It sounds very unlikely to me. There's definitely not an ancestral connection. The Ashkenazi Jewish people are part Middle Eastern and part Italian.
Thanks very much. And there's a question up there.
Thank you very much for the talk. Really interesting, fascinating. To which individual or organisation should we focus our lobbying in order to get the screening that you're advocating?
I don't know the answer to that. I have a meeting with Neil Gray set up, who's the Scottish Cabinet Secretary for Health and Social Care. So you could write a letter to him. I'm just beginning to learn about the shape of these things and how to try to have an effect in politics. So I literally don't know the answer, but I would be very grateful if people were on this side when the time came to make a noise about it.
Okay. Well, thanks very much. That's great. I think we'll finish up with the questions there. But all that remains is for me to say thank you very much to Jim. It's very good to have had you.
Thank you.